In Alias 2012 there are some changes and additions to the filleting tools. Firstly, I'll look at the improvements in the Surface Fillet control window. In previous versions there's been a Simple and Advanced tab, but this has been removed in Alias 2012, so all the options are now available in the main window. The surface structure settings have now been grouped together into a new fillet structure section, which makes the window more compact. And the peak curvature option has been removed and is now replaced by a default form factor of 0.5. And this form factor is part of an update to the terminology and workflow for G2 and G3 fillets. So I'll start with this terminology. Firstly, what used to be called peak radius is now called center radius. This is easy to understand when we have a circular fillet, as a single radius value creates both the fillet arc and determines the tangent offset, which is the points where the original curves are trimmed back to. If we keep this same tangent offset, but build a G2 fillet instead, then the center radius takes on a different value, which determines the shape and peak of the fillet. These two values are related by the form factor, which was previously called the peak ratio. And if we have a look at some examples, you can see how that ratio of the two values creates different fillet shapes. But as well as the terminology, the emphasis in the workflow has changed. In previous versions, the tangent offset was the main setting, and then you chose a value for either the peak radius or the peak ratio. In Alias 2012, the emphasis shifts to the form factor as the main setting, as it provides a consistent fillet shape regardless of the other two settings or the physical size of the surfaces. Here are some example fillets at the back end of this car model. This one is a circular fillet of 50 mm, which gives me a constant arc, as I'd expect. If I now switch to a G2 curvature fillet, the radius setting switches to a tangent offset of 50 mm, with a form factor of 0.5, which gives me the same default shape and CV layout as before. Going up to, say, 0.75, the shape gets closer to a circular fillet, and the CVs are more evenly spread out. And then down at 0.35, for example, I get this characteristic bunching of the CVs, which gives me a sharper peak. I can switch to specifying the center radius instead of the tangent offset, but the form factor stays as my main shape control, giving me the same characteristic CV layouts for each value. And this form factor is also consistent across different size fillets. So on this cant rail I have a much larger fillet, but changing the form factor still gives me the same characteristic CV layouts, regardless of the size. So as a designer, it's easier to understand how the form factor relates to the shape that I get. So even on these rear light surfaces where I have a much smaller fillet, which is caudal, again I get a consistent shape when I choose the same form factor setting. So that's a typical range of form factors you might work with for radius fillets. But there's a special case for caudal fillets that I want to show you. Here, because the two surfaces become more tangent as they approach the edge, the radius fillet fades out. So here I'd typically choose a caudal fillet. But there's an old problem with the CV points going out of line in these situations, and it's worse the larger I make the fillet. But this can now be solved by choosing a form factor value of exactly 1, which smooths out the irregular flow of control points. And it even works well on the really large fillet. The next improvement is to the explicit control options available in Alias Automotive and Alias Surface. You've always been able to set explicit values for the length of the fillet, but now you can also set it for the cross-section too. And the two directions, length and section, are now clearly labelled in the control window. And here are some specific examples where it'll make a difference. Previously, a G2 curvature fillet would be fixed at degree 6 for the section, but now you have the flexibility to choose, for example, degree 5, and have the minimum number of CVs, which still gives acceptable accuracy, but with a lighter surface. If you choose G3, however, you don't have this choice, as a degree 7 is the only option that gives enough CVs to maintain the required continuity. But if I go the other way and create a circular fillet, I can now choose to reduce the section to degree 3, sacrificing a small amount of accuracy to gain lighter geometry. So you now have full control of the fillet surface structure. Explicit control and the form factor are also applied to a new tool, Symmetric Fillet, which is available in the automotive and surface versions of Alias 2012. In terms of functionality, it sits between a variable surface fillet and a freeform blend. The variable surface fillet is controlled by different radii at different locations, so you don't have direct control of the tangent lines. But it has the advantage of creating a perfectly balanced blend, in this case a circular arc. With the freeform blend, you can create and control the tangent lines directly, but that freedom means you can't guarantee that you'll get a balanced, even blend. The new Symmetric Fillet has the best of both. You create one of the tangent lines directly, in this case I've projected a curve on surface, but the tool then accurately calculates the second tangent line, and a perfectly balanced, in this case circular fillet surface is built between the two. Here are some examples on the car model. On the front wheel arch, I want to create a blend that washes out towards the front, so I'll start by projecting a curve that defines a tight blend at the back, fading out to a wider one at the front. Now I can use the new Symmetric Fillet. First I pick the two curves on surface and accept, and then the surfaces on the other side. And finally I choose the direction of the fillet. I can tidy up this end by opening the control window and using Edge Align. And I have a new flow control option called Modify Range, which uses only part of the curve on surface. I can choose G2 Curvature, and here I have the form factor slider, and it works exactly the same as it did with the surface fillet, making the blend sharper or softer. So if I shade these surfaces up the same colour, you can see that I get a really nice washed out blend. At the rear wheel arch I've got an unusual example where this red symmetric fillet is built from the edge isopalm of this draft surface. The draft won't form part of the final model, but it's being used to provide a controlled angle for the edge of the fillet, and I can modify this angle, and the symmetric fillet is recalculating the second tangent line each time and building the balanced blend surface. And this level of surface discipline gives a very high quality result. And finally, a couple of examples where I've used Symmetric Fillet to solve filleting problems on this detergent bottle. At the neck, a radius surface fillet becomes pinched on the right side, and if I try a caudal fillet, it can't cope with this shallow edge. But it's very simple to project a curve exactly where I want to start the fillet, and then use Chain Select to pick all the curves on surface, and then build the symmetric fillet which softens out nicely on this lower edge. On the base surfaces, here is a perfect example of the variable surface fillet not giving me the shape that I want. So again, it's very simple to just create and project a curve to define the tangent line, and then use the symmetric fillet to create a balanced, accurate blend, and to create this second tangent line on the bottom, saving me time and giving a really controlled result. So that covers the filleting improvements in Alias 2012. In Surface Fillet, the control window has been better organized, with an updated form factor workflow for G2 and G3 fillets. And in Alias Surface and Alias Automotive, explicit control has been expanded, and there's a new symmetric fillet tool.